Hi everyone. Sorry this second problem from the lecture notes is going up a little bit later than I anticipated. I had some trouble with the recording software last night. But anyways, here we go. This is the second problem from the chapter 7 lecture notes. We're given a production function, Q equals 4KL. We're given the marginal product of labor, which is equal to 4 capital, and we're given the marginal product of capital, which is equal to 4 labor. All that means is that for every 1 unit of labor, you can substitute 4 units of capital. We're also given a wage rate of $8 and a rental rate of capital of $10. The first part of the problem asks, in the short run, with capital fixed at 10 units, what is the total cost of producing 200 solar panels? So our production function up there is the production function for a firm that's making solar panels. All we want to figure out is what, in the short run, is the total cost of producing 200 of those. So how do we do that? We start off by substituting in our values for Q and capital. So Q is equal to 200, and like the question says, capital is equal to 10. So in our production function up here, we can substitute 200 equals 4 times 10 times L. That'll let us solve for L. So we can just do some simple algebra. 200 equals 40L, and L equals 5. We're not quite done yet though. That just tells us how much labor we're using. So now we know how much labor we're using, and we know how much capital we're using. It's fixed at 10. So we have to put those values into the total cost equation. Remember, total cost is equal to the wage rate times the amount of labor plus the rental rate times the amount of capital. In this case, we have 8 times 5 plus 10 times 10. So our total cost is going to be equal to 40 plus 100. So our total cost is equal to 140. That's our total cost in the short run. You can remember that it's the short run because we have a fixed level of capital. Right? Now, the next part of the question asks, what does the firm do in the long run to minimize costs while still producing Q equals 200 solar panels? It also asks, how much will a firm save? When it's asking how much will a firm save, it's talking about how much they save in the long run relative to the short run. Because they're able to change the amount of capital that they're using in the long run, you'd expect that they would better be able to mix and match the amount of capital and labor to find the cost minimizing combo of capital and labor. So that's what we're going to do here. That no longer is capital fixed. We have to solve for it. If you remember back to chapter 6, costs are minimized when the marginal rate of technical substitution of L and K, or of L for K, is equal to the ratio of costs for L and K. I know that's kind of a mouthful. All that means is that we're going to put the wage rate on top of the rental rate, and that's going to be the marginal rate of technical substitution. Okay. Once again, costs are minimized when the marginal rate of technical substitution of L for K is equal to the ratio of costs of labor to capital. Let's show that in math. I think it'll be a little more clear. So we have the marginal rate of technical substitution of L for K. Like I said, that just means the wage rate over the rental rate. We look at the marginal product of labor and the marginal product of capital, which were given up in the original part of the equation up there. So the marginal product of labor is 4K and the marginal product of capital is 4L. So we can say 4K over 4L and simplify that and say K over L. We also say that the wage rate over the rental rate is 8 over 10. So we can set the marginal rate of technical substitution, which is here, equal to this to solve for either K or L. In this case, I'm going to solve for K because we have K in the numerator right here. So we're just going to say K over L is equal to 8 over 10. Multiply the L over, so K equals 0, let me say, oops. K equals 8 over 10L, or K equals 0.8L. Whichever one you're more comfortable with. I like the decimal better. I think it makes the math a little easier. So what does this mean? What does this K equals 0.8L actually mean? All that means is that the ratio of capital to labor to minimize costs should be 0.8. What does this mean in even plainer language? Just that for every 1 unit of labor, for every 1 worker, the firm should use 0.8 units of capital. Okay, that's their cost minimizing combination of those two things. For every 1 unit of labor, they should use 0.8 units of capital. Okay, the next question then is, what does that cost? What does this combination cost? We also want to compare it to the short run costs. How are we going to figure this out? We're going to go back to our original production function, our Q equals 4KL, and we're going to substitute in our K equation from above. So we're going to have, remember, we're still trying to produce 200 units, so we're going to say Q equals 200, 4 times 0.8L times L. Do some algebra. 200 equals whatever that is, 3.2 L squared. And if you pull out your calculator, you should find L equals 7.91. So that's the efficient level of labor allocation in the long run. We still have to find our capital, however. This part's easy. We are just going to solve for capital by substituting in our 7.91 into our k equals 0.8 L equation, which means k equals 0.8 times 7.91. Again, pull out your calculator. K should come out to 6.33. Okay. Now we find our total costs. We've solved for labor, we've solved for capital. Now we just have to solve for total cost. Total cost in the long run. Okay. Total cost, remember, same as in the short run. Total cost is equal to the wage rate times the amount of labor plus the rental rate times the amount of capital. So in our case, we have TC is equal to, still costs 8, the wage, and then we're substituting in our value for labor, which we found was 7.91, and doing the same thing for capital, 10 times 6.33. One more time, take out your calculator, add those up. You should find the total cost is equal to 126.58. Okay. So now we're just trying to figure out whether or not the short run total cost is more or less than the long run total cost. We solved for the long run total cost here, and before we solved for the short run total cost, in the first step, we said the short run total cost is equal to 140. So obviously, the short run total cost is greater than the long run total cost. Let me write that down here. So it's about costs costs in the short run are about whatever that is, $13.42 more expensive than in the long run. Again, this shouldn't come as a big surprise. We know that in the long run, the firms have more flexibility. They can substitute labor and capital, but in the short run, they're constrained to only changing their labor. This is reflected in the fact that in that first part, when we solved for the short run total cost, they had their capital fixed at 10. So going forward, whenever you see you have a fixed level of capital, that's when you know that you're operating in the short run. Think about a firm that can't sell off a factory that it bought. It's hard to sell off a factory over the course of a couple weeks or a few months, but that's something that they could do over the course of a number of years. That just reflects the difference between the short run and the long run. Okay. There's another problem that's very similar to this one in the lecture notes. I suggest giving it a try to make sure that you understand the process. Everything's the same. The only difference is that the numbers have changed a little bit. Okay. Again, sorry that this is going up a little bit later than I was expecting, but hopefully that isn't too much of an issue for you guys.